So in this video we're going to try and solve this problem. It's finding the eigenvalues and the eigenvectors of this matrix A0, 1, minus 2, minus 3. So we'll start with this characteristic equation, A minus lambda times the identity matrix. The determinant of that. Get rid of this. So to break this down then, the identity matrix is basically just a matrix the same size as the matrix you're looking at, except one's on the diagonal. So then we'll sub in A, so this will be what the question is. So this is given 0, 1, minus 2 and minus 3, and we'll multiply lambda by this matrix, the identity matrix, and we find out that that just turns the diagonals into lambdas. So this is the characteristic equation that we use to find the eigenvalues. So you end up, when you subtract these, you get 0 minus lambda up here, you get 1 minus 0 over there, minus 2 minus 0, and minus 3 minus lambda. And this is commonly known as the determinant. So these two lines is basically trying to find the determinant of what's inside the two lines. So basically what this requires is multiplying the top left corner by the bottom right hand corner, and then putting a minus sign in and subtracting then the multiplication of this corner. So it's this corner minus this corner. So we'll do that out here. Might as well just do these out. Let's get them cleaned up. And minus 3 minus lambda. So then when you find the determinant of this, as I said before, you get minus lambda multiplied by minus 3 minus lambda, and remember the minus sign, that's easy to forget. And then you have minus 2 multiplied by 1. So when you multiply this out, you get 3 lambda plus lambda squared plus 2. Yeah, and then I don't like the look of that, so I like to kind of put the highest power first and the constant last. So keeping that down there, we'll get rid of everything above it. So yeah, when you find the factors of this, you end up getting lambda plus 2 and lambda plus 1. And that turns into lambda equals minus 2. That's your first eigenvalue, and then your second eigenvalue is minus 1. So yeah, you have, this is your first eigenvalue, and this is your second eigenvalue. It doesn't matter which one's which, it doesn't matter if you ended up saying that minus 1 was your first eigenvalue and vice versa. But yeah, if you were given this question, then this would be 1/3 of the answer. Okay, so we're on to the second part of the video, which is to try and find the first eigenvector for the first eigenvalue. So to start this off, you basically have this definition for eigenvalues, where if you were to multiply the eigenvector by the matrix, it would turn out to be the same number as if you multiplied that same eigenvector by the eigenvalue. So We use this to try and find the eigenvector, but we also use it later on in this video to try and prove that we found the right eigenvector. So it's kind of like to proof check the answer. So you then turn that into a minus lambda, or that first eigenvalue, and let that equal to 0. So then you can sub in the values for, first of all we can make the equation so that it works for both eigenvalues. So you can take this equation down. So this is just using, the numbers for a, which is given at the start of the question. So the first number given in a is 0, and just take away lambda 1. Then the second over here is number 1, down here minus 2, and down here is minus 3, but we take away the first eigenvalue from that. So this is how it's done. It's only the diagonal from the top left to the bottom right that's subtracted, and you multiply this by v1 and let that equal to 0. So you can use this and for the next eigenvalue and just sub in eigenvalue 2 for this. So take down this equation for the next part of the video. So we're going to be subbing in minus 2 now. So 0 minus minus 2 is, so I'll just put in sub in. So we're subbing in here, and it ends up being 2, 1, minus 2, minus 1. Yeah, minus 3 minus minus 2 is minus 1, yeah. So then that, and so we'll break out this eigenvector into its components. So we'll have v1, 1, and v1, 2. So this will just be the x and y components of eigenvector 1. So that's equal to 0 then. Okay, so what we do then is multiply the vectors by each other and compare them to 0. So for the first, so we'll come out with like a simultaneous equation, and each one of them will have v11 and v12 in them, but they should both kind of give us the same answer. So you'll see here, hopefully if this is correct. So we have 2 by v11 plus v12 equal to 0. So this is from multiplying the 2 by v11 and the 1 by v12. Now next then we're going to get, so we're going to over here turn this into another way so that we can equate v11 with v12. So we'll say this, 2 v11 is equal to minus v12. So that's the first one. And the second one now, minus 2 by v11 multiply, or plus minus 1 by v12. So when we do the same thing as before with that, we'll end up with the same result. We can show that as 2v11 is equal to minus v12. So what you do at this step is you try and sub in a value for either v11 or v12 that'll give you a number for the other. So then that will become your eigenvector. So for this we'd sub in 1 for v1, 1. So if you subbed in 1 here into either one of these, so sub in 1 for v1, 1. So that will give us 2 by 1, which is equal to minus v1, 2. Yeah, just to spell that out, that's v1, 2 is equal to minus 2. Okay, so if v1, 2 is equal to minus 2, and if we said v1, 1, we subbed in 1 for it, that means our eigenvector, so I'll just put this over here, eigenvector for eigenvalue 1 equal to minus 2 is, so what did we say again? v1, 2 is equal to minus 2, and v1, 1 is equal to 1. So as before, so I'm just going to try and prove that to you guys, and to myself, and to the examiner. So then we get minus 2 and 4 on the left. So when we multiply out the right, we get, surprise, minus 2 and 4. So that's again a good thing, because that means that the equation is satisfied with this eigenvalue and eigenvector. Yeah, so we're gonna now sub in 1 for, we're gonna sub in 1 for v21. So that gives us okay, 1 is equal to minus v2, 2. So v2, 2 is equal to minus 1. Boom. Okay, so then we know that our second eigenvector is 1 and minus 1. Based on v22 is minus 1, and we subbed in 1 for v21. Okay, so let's check that out. And again, that 2 equals lambda 2, v2. So then A is 0, 1, minus 2, minus 3, 1, minus 1, and minus 1, 1, minus 1. Okay, so in this vector over on the left hand side, you have 0 by 1, 1 by minus 1. It's looking good already. Minus 2 by 1, and minus 3 by minus 1 is plus 3. Minus 1 by 1 is minus 1, and minus 1 by minus 1 is 1. So then this minus 2 plus 3 turns into 1. Okay, so that's QED. So then that would make your second eigenvector oh, sorry. We already have it right. Don't want to get it wrong. 1 and minus 1.